Our next episode from How to Read a Book, The Classic Guide to Intelligent Reading by Mortimer J. Adler and Charles Van Doren. Now we are on chapter 17, and we are talking about how to read science and mathematics books. I have really been dreading this one, but you know, it really wasn't that bad, so we're going to get through it. I have to say, our authors have a refreshing take on reading science and math, and this was a surprise for me, and it was actually delightful. It inspired me to try my hand at reading a classical work of science, so I'll talk about that at the end. They make it relatively painless, and they have excellent reasons for encouraging people to try science books. By the time you get to the end of this video, you should have a more relaxed perspective on reading science, even classical science books, mathematics books, and a better understanding of why you should make the attempt. But now it's time for a tea break. Today I'm drinking Harney's Irish breakfast tea out of an Emerson Creek pottery mug. I've been friends with this family for decades, y'all. Sometimes they give me mugs for gifts, and sometimes I buy them myself, but I'm addicted to their mugs. So anyway, here we go. I do love breakfast teas. I love English breakfast teas, Irish breakfast teas, and Scottish breakfast teas. And it's almost St. Patrick's Day, so seemed like the appropriate time to drink it. Okay, back to our book. I have dreaded this chapter ever since I started reading this book, but I dreaded it for naught. It was actually a delight to read. Now, sometimes I enjoy popular science. I haven't read any in years. I tend to read history and biographies more than anything else now, and I'm not sure why I started doing that. But anyway, I've enjoyed myself. I like history and I like biography, but I think it's time for a change. I think it's good to stay updated and kind of well-rounded if you can. Before we get started, just to make sure you understand, in this book, it was written in the early 1970s. They are not going into an in-depth discussion about how to parse out scientific articles that have been written in maybe computer science or something that you don't understand, bioengineering or, anything like that. They are not talking about reading scientific articles written for scientific people. Instead, they are talking about classic works of science that are full-length books. They touch a little bit on popular science articles, and then they also talk about popular science books that are currently published, well, not currently as of when they wrote, in full-length book form. Remember that the popular books of their day that I am going to talk about are over 50 years old at present. If you know of any great recent science books, leave them in the comments, because a lot of people really do enjoy science books, and there are a lot of great ones out there, and I'm not going to touch on any of those today. Before the year 1900, most science books were not written for other scientists. That was kind of hard for me to wrap my mind around, but it's true. Today, most science writers write for their peers. They're trying to get, their research out there and that sort of thing. Back then, they were written for people like you and me. So, surely that would be an encouragement to give them a try, right? But this difference is also why so many of us today find science writing so intimidating. We don't have the background we need to understand a lot of it because we are not the author's intended audience. This can be true even for so-called popular science books. I confess that 30 years ago or so, I attempted to read Stephen Hawking's A Brief History of Time, and I gave it up after the second chapter. Now, maybe you read it and you thought it was a breeze to read and understand, and if so, my hat's off to you. That's fantastic, but that was not my experience, and it was a little discouraging. And they also point out that some scientific popularizations are good and some are bad. I have attempted in the past to read some popular math titles, and I gave up after a few pages. Now, was that the author's fault or was it my fault? I don't know, and I can't remember the titles to tell you what they were. At the time of writing the book, though, they said that this was about to change because studying the history of science had become a respected enterprise for the first time in years. You know, the old saw, they bring that up, those who can't do, teach. They said that was the attitude of most scientists towards people who studied the history of science back in the day. They said that was a huge mistake, and they predicted that there would be an exponential growth in popular science titles. And I don't know how many popular science titles were released in the 1960s, which was their recent history, but these days I know there are lots. And some of them do sell extraordinarily well. But while they're enthusiastic for the prospects of popular science writing, they still urge readers like you and me to read the classical science works. Since science writing is expository writing, they say the most important advice they can give is figure out what problem the author is trying to solve, and then state it as clearly as you can in your own words. That's the most important thing you have to do. If you've done that, you've done a great deal towards understanding classical science. On page 258, they had a good statement that I thought I should read. Let me see if I can find it here. Most important of all, it is an activity of the mind that is essential to education, the central aim of which has always been recognized from Socrates' day down to our own as the freeing of the mind through the discipline of wonder. I think that's an amazing quote. That's why I like to learn. There are two aims of classical science writing in general that you need to keep in mind. First, the author tries to describe the phenomena they are observing as accurately as possible. That could be from an experiment or just from observation, whatever. And then they need to trace the connections between different types of phenomena so that they come together and make sense. To determine the author's bias, you need to take note of what the author assumes versus what they prove. It's okay in science writing if the author is biased. I mean, people really can't keep bias out of everything. That's just not possible. But they say it's okay as long as the author admits they are biased and are transparent about their own assumptions. So that's kind of refreshing, I thought. When it comes to picking out lead terms in science writing, just choose the uncommon or technical terms. I mean, they say that this is actually much easier in science writing than it is in a lot of other kinds of writing, particularly literature. Use a dictionary to define the terms the way the author intends. Keep in mind that scientists tend to be more general in their definitions than in other types of writing because they want to prove something is universally true. I thought that was pretty interesting. Like I said, this was an interesting chapter. Now, they said you may run into two main difficulties when you're trying to read scientific works. First, you have to understand the inductive arguments, which is based on observable evidence. You need to, and in order to do that, you need to have access to lab equipment that the scientists use for whatever they're studying, like praying mantises. You need to have access to whatever it is that they are studying. But then, of course, this isn't always possible. But they say you must become acquainted with the author's evidence firsthand. This is not an option. If you need to go to a museum to study something in person, do it. If you need to do simple science experiments, do it. And that's why they say classical reading is so much easier, because a lot of the experiments scientists did 200 or 300 years ago just used common materials that we have today, like pieces of paper with holes in them. I mean, it's not that difficult. So they said, do your best. If you can replicate an experiment a scientist did using things in your kitchen, equipment in your kitchen, ingredients, or your backyard, do it. And if you can look up the experiment online, this is where we have an advantage today. If you can look up somebody doing an experiment online, do that. They also point out in this section that you don't need to read. Listen to this carefully because this was such good news to me. You don't have to read the entire work all the way through. Yay! I thought, like they point out, I'm probably mispronouncing a lot of these names today, and I'm sorry, but Lavoisier, I think, his Elements of Chemistry, that was once the premier chemistry textbook, but now it's out of date. But they say just reading the preface to that book has a great deal of value because it itself improved the language of chemistry. The second thing that interferes is mathematics. I'm sure a lot of you can relate to that. I know I can. But they take a lot of time here trying to calm your fears. They say that, and this is true, math is just another language. Instead of being based on words, it's based on symbols. They said that most people at the time they were writing, over 50 years ago now, did not understand math because it wasn't taught very well. They had a touching amount of faith in the new math teaching methods. They say that in the future people will understand math better. Now, I went through high school in the 1970s after this book was written. And I don't know if I was taught new math or not. I have no idea how I was taught, but honestly, I understood math better in high school and in college than I did in elementary school. So there may be something to what they're saying, I'm not sure. First, they say learning math is like learning to read at an elementary level in any other language. English to Zuni. They suggest beginning with Euclid's Elements. Now, I knew nothing about this, so I looked it up on Project Gutenberg, and I've linked that below. You can read Euclid's Elements for free if you'd like to. They explain in detail how to use this book to go through and understand the first 3 paragraphs in the first book. Now, Euclid, if you didn't know, did not invent math. I had it in the back of my head that Euclid just came up with all this stuff because he was such a genius. No, they said it had been around. The Egyptians had it. I mean, you know, people understood it for probably 1,000 years or more before Euclid came along. But he took what was known of math in his day and explained how math works. So to do so, he set out definitions first, on which he based rules or postulates. He also used axioms, which are rules that apply to all of mathematics, not just geometry. Now, these postulates and axioms are used to prove propositions. Remember proofs in geometry? Okay, and here's a little aside, you know, the ADHD in my head. I always had a pretty easy time of algebra. I understood it. I understood the little bit of trigonometry that I learned. I took, you know, math classes in college. I found them super easy to understand. Geometry was terrible. I took it in 9th grade and I did not understand it. And I looked up, you know, Euclid's book, and I went back and watched some videos. Just these first 3 paragraphs of Euclid, I've got those linked below too. Khan Academy and Online Mathematics, I think were the names of them. And I remembered why. I mean, just all those rules and postulates, I couldn't keep them in my head. Well, that was interesting. I had a tornado warning go off on my phone, and because it went off on my phone, I stopped recording. And now I'm lost and don't know where to start again. So I'm hoping this will make sense. I hope I pick up in the right place. I went back and recorded everything and then found out that the recorder didn't work. So here, we're just going to go with it. Handling math and science books is a different thing. They encourage you to go ahead and give this a try. Try to read science books with math in it, because they say that you probably can handle reading elementary math better than you think you can. And I agree. If you want to read a scientific mathematics book, you have no choice. Now, this is a scientific mathematics book, you know, where the whole point is to understand mathematics. They say if you read a textbook like that or a book like that, you have no choice but to work through the entire book with a pencil and paper and do the work yourself. Now, most lay people probably don't want to do that anyway, so they don't talk about it a lot. I know I'm not interested in that. But if you want to read a scientific book with mathematics in it, skip the math if you don't understand it. You heard that right. They said skip the math, and I think that's a great idea. They use the example of Newton's Principia Mathematica. What you want to do is understand the overarching problem that he seeks to solve. Then you want to grasp the system that he sets out to solve it, but skip the diagrams unless you really want to study them. By the time you get to the 3rd book, you'll understand the basis of his system, but also the great problem of almost all subsequent physics, and that's pretty cool. If you find things too obtuse, skip along, picking up what you can, but pay special attention to the conclusions or summations at the end, as in Newton's optics. They're well worth reading to understand science in general. Don't skip reading works with math. They say it's absolutely necessary to understand many scientific works, and they're worse. The works themselves are worse. Y'all, we're getting ready to have a bad storm here. That's why I'm kind of distracted and I'm kind of hurrying. Okay, let me get back to this. They say it's absolutely necessary to use math to explain a lot of scientific concepts. For example, Galileo wrote The Two New Sciences in dialogue format, and they said that it's a whole lot more obtuse and hard to understand because he didn't use math to explain astronomy. They finished the chapter with a note on popular science. This is different from classical in that first, scientists today, when they write these books, report on the results of experiments rather than walking you through them, so you don't need to go try to replicate it yourself. And second, they tend to have very little math. They note that if you read scientific articles in magazines like Scientific American, you're at the mercy of the honesty, reliability, and understanding of the person who is reporting on the topic, just like with current events. They give examples of 3 popular science books from the early 1970s and describe the reasons to read them. The first is Alfred North Whitehead's Introduction to Mathematics. They said, read this to understand what math is all about. It's crucial to understand math to understand our age. They liken it to religious mysteries in days gone by. You know, people didn't understand what was going on in the temple at Delphi or whatever. Now they say it's kind of like science. Mathematics has taken the same thing. It's just like a mystery religion or a mystery language that we all kind of need to crack the code on. Second, they recommend Lincoln Barrett's The Universe and Dr. Einstein. They say that this explores the history of the atom for lay people, and they said it concerned people of their day because they were so close to the nuclear attacks on Hiroshima and Nagasaki, and people were still concerned about those threats back then in the 70s. Well, we're still concerned about them today, aren't we? So I would say this would be a good one to give a try. And third, Barry Commoner's Closing the Circle. The theoretical conclusions of this book is that we are destroying the environment and that people should be concerned about that in the 1970s. Well, we haven't made a lot of progress on that. We had for a while, but now we seem to be going backwards, and that concerns me a great deal. So this may still be an important book for us to read today. I think we've allowed ourselves to be distracted by consumerism and digital entertainment and ignored problems that are really there, and that both dismays and frightens me. And then they conclude the chapter by pointing out that a mathematician is just an ordinary man, not a magician. And that's a good point. If they can do it, a lot of these people are not any smarter than the rest of us. They just are willing to focus and learn something new. And that's a good point. We have to have a grasp, they say, of what science has to teach us to truly understand the world. I would agree with that. And that's a good reason to attempt the reading. So what do you think? Are you willing to give a science and or a math book a try? Do you have any that you'd like to recommend? Leave a comment below so we can all pool resources. Now on to what I'm currently reading. This is interesting. I went into my little room where I keep my to-be-read pile, where I have about 50 nonfiction books piled up, and looked for a science book to read next. I couldn't find one. I have let myself slip entirely into reading history and biography, and I do need to rectify that. But what I decided to do was read one of the classic books they recommend in the back of this book, one of the classic science books. So I chose Hippocrates' medical writings. I have found a book on Project Gutenberg to read for free. Right now, and here's my plan. I am not going to read this book. I'm going to follow their suggestions. I'm only going to give the book an inspectional reading. I'm just going to read the headings, the first sentences of each chapter, the last sentence of each chapter, thoroughly read the introductions, and thoroughly read the last paragraphs, and let it go at that. And then if I'm still interested, I can watch or I can listen to the audiobook of Hippocrates' entire work. Right now, I've been working my way in an inspectional reading through the translator. He is a doctor from the 19th century, and he's spent over 150 pages introducing this book. So I've given that an inspectional reading, and I'm just getting to dive into Hippocrates' actual writing. So I consider this an experiment in my intellectual development. And as for fiction, I am still working on The Herbalist, which was the first book I talked about in my last video, to improve my understanding of the magical realism genre. So that's it for today. I hope that you are inspired to give math or science reading a try, and if you are, let me know down below. And until next time, happy reading.